And we're back and better than ever in 19-4 where we're dealing with neutralization reactions. In the first podcast of this section, we introduce you to an equation that allows you to determine unknown concentrations of acids or bases given the amount of the volume of solutions that are required for neutralization. And that equation was, let me get my pen ready again here, that equation was the concentration of the hydrogen ion times the volume of the hydrogen ion will equal the concentration of the hydroxide times the volume of the hydroxide ion, and of course those are all in solutions. Now what we're going to do is we're going to show you the lab technique, which is called a titration, that's used to determine these unknown concentrations. Alright, so let's scroll down just a little bit further. There we go. What you do is you take a given amount of, say, acid, and this is what we'll be doing in lab. Let's do this in red. You're going to take your unknown, let's just say hydrochloric acid, because that is likely what you'll be using in class. You take your unknown acid and you put it into a flask. Now this says it's a conical. Usually we call it an E flask or an Erlenmeyer flask. Alright. And you know how much you put in there because you measured it out yourself. So you have a known volume of HCl. So we're all set with that. And you put this thing on a magnetic stir. I'll show you what that looks like. It's got a flea in there, and this thing will spin to make sure that it continually mixes. And then in what's called a burette, let's go with blue here, inside of this burette, you're going to put your known sodium hydroxide, or whatever base you want to use. Alright, you know the concentration of it. And it's going to start at a certain level. Let's just say that it starts up here. Okay, so this whole thing is filled all the way through. What's going to end up happening is you're going to drip your base into the acid. So we'll color this red for now because it starts off acidic. You're going to continue to drip that in until the indicator changes. Now how do you adjust that? Well, you have this tap. This is also called, in some places they'll call this the stopcock. Sometimes they'll call this the valve. Either way, that's what we're talking about there. And you're going to drain down your base until this reaches the equivalence point. Now most of the time this is going to go from colorless to pink. And once it turns pink, if you're using phenolphthalein, then you know when to stop. But you don't have to use that. You can use a variety of different indicators. You're going to know how much NaOH that you're using. How are you going to know it? Because you're going to record the starting value, and as this drains down, you're going to record the ending value. And you're going to know exactly how much that you're going to be adding based on how much you started with and how much you end with. Alright. Now the deal is when you're reading the meniscus, and this is a little close-up over here, you got to make sure that you're looking at this thing at eye level and that you look at the bottom of the meniscus. Alright. So if I label this, let's say this top number is 1, 2, 3, 4, 5, 6, and so on and so forth. You have to be able to look not up at the top here, not up here, but at the bottom of the meniscus to read it. The other thing is you do have to read between the lines. Now this number happens to be, it looks like right in between the 3 and the 4. So if this line here is 3 and this line here is 4, it looks like it's between the line. Now you might say, well, it looks like it's exactly between the line, but in reality it isn't. The middle of the meniscus might be sitting right in the middle, but you don't read it from the middle, you read it from the very, very bottom tip, and that bottom tip is fairly close to 4. So I actually would call this myself maybe 3.7 or 3.8. Now we'll have to practice that in class, but you got to make sure that you're reading the very bottom tip of the meniscus, not right in the middle of the meniscus. You don't estimate the average meniscus. You got to go right to the very bottom tip of that bubble. All right. So here's the deal. You know how much acid you put in because you put it in yourself. You know the concentration of the base that's in the burette because it's accurately known. If you don't know that, you can't do the titration, but it's on the bottle. You know the volume of the base needed to get to the neutralization point because you can read what you started with and what you ended with to get to that equivalence point. And once you know all of those, you can solve for your unknown acid concentration. All right? So let's go ahead and try a calculation here and see how it works. If the following data was collected during a titration in which 0.10 molar sodium hydroxide was added to 15 milliliters of unknown HCl, what is the concentration of the HCl? So once again, you need to know your equation, or you need to at least have it written down, where MHVH equals MOH VOH. And we're looking to solve for the concentration. So, do we know the volume of the acid? Yeah, it's 15 milliliters. Okay. Of course, we still don't know this, so we have MH times that. Do we know the concentration of our base? Yeah, it says right on our bottle here. That's going to be 0.10 molar. Now remember, because you only have one hydroxide, the concentration of the hydroxide is the same, so it's 0.10 molar. Do we know the volume of the base added? Well, it doesn't tell us in the paragraph, but if you look at the table, you have your initial volumes, your final volume, and the total volume used. So if the burette started at 0 and ended at 9.5, when you subtract those two, that's going to equal 9.5 milliliters used, obviously. When you do your second trial, if you started at 9.5 and ended at 19.1, the difference there is 9.6. And when you take a look at your final trial, if you started at 19.1 on the burette and ended at 28.8, you must have added 9.7. That's the difference. So when you take an average of those, it's an average of 9.6 milliliters. That is on average how much base was needed to neutralize your acid. And so that is the amount of base that we're going to plug into our equation. Alright, so now all we need to do is divide both sides by the 15 milliliters. Divided by 15 milliliters. Of course, the milliliter unit divides out. These terms divide out completely. And when you take your 0.1 times 9.6 divided by 15, MH plus is going to equal 0.064 molar hydrogen, and because there's one hydrogen for every one HCl, that's going to be the same, 0.064 molar HCl. You'll be doing one of these types of titrations in class, so you need to know how to do those types of calculations. It will also show up on the test. All right. In the next podcast, we're going to take a look at another method of determining an endpoint in lab using a pH versus volume of base added graph. Okay, we'll see you next time.